Hello, today's presentation is titled Experience Dynamic Braille that Responds to Reading Gestures and is brought to you by Dream Vision Group.
Dream Vision Group is a blind-owned company specializing in quality Braille and low-vision products with an emphasis on training and support.
Thank you for joining us. For today's agenda, we're going to cover the unique benefits of the Active Series Smart Braille displays from HelpTech gMBh in Germany. We are going to discuss the following topics. First, we will answer the question, what is Active Tactile Control, ATC? Well, to start, it's concave cells and sensors under the Braille pens. Next, we will look at how Active Tactile Control helps Braille learners by creating custom screen reader responses and learning profiles. After that, we'll talk about how ATC helps teachers. We'll show you the Reading Log, Player, and Analyzer apps, as well as the Tably, HT Echo, and HT Instructor Android apps, and the HelpTech Plus iOS app. And just for fun, we'll finish up by showing you some games and a unique Braille music feature called MusikBraille.
So, let's get started. What is Active Tactile Control?
ATC, or Active Tactile Control, refers to a type of patented curved ergonomic Braille cells that have sensors under each pen and are concave in shape. This shape is designed to fit the pads of your fingertips and supports a more natural hand position than stretching the fingers to read on traditional flat cells. These ergonomic cells can extend reading times by minimizing hand fatigue. And yes, you heard that right, these cells have sensors under each pen. They are the only Braille displays in the world with this technology. This allows the Braille device to track a reader's finger position. Basically, the display knows where your fingers are. It knows which Braille characters you are reading as you read them. This technology, the sensors under each Braille pen, makes a host of unique features possible and significantly benefits Braille students and teachers. Let's dig a little deeper. We mentioned that Active Tactile Control, those sensors under the Braille, allow the display to know what Braille you are reading as you read it. Well, we call it Braille that follows your fingers. One of the simplest benefits of ATC is that it can automatically refresh the Braille when your fingers reach the end of the display. This is different from the auto-scrolling at a timed interval feature on other displays. Basically, the device waits until you get to the end of the line, then advances to the next line. You can get up to take a phone call or get a drink and come back to exactly where you left off. Here's a little clip to show you what we are talking about.
Braille automatically refreshes when you reach the end of the display. No need for manual scrolling. Seeing this in action is a great way to demonstrate that ATC knows where the reader's fingers are.
Now that we've explained ATC, let's talk about how ATC helps Braille learners. Because ATC detects your finger position on the display, this information can be used to trigger custom JAWS actions that can enhance Braille learning and reading comprehension. So, what exactly does that mean? Well, as we've mentioned a few times, ATC uses the sensor under the Braille pens to know where your fingers are when reading. So, this means ATC can provide instant spoken feedback when a student reads a given word or character. That's right. JAWS will now speak as you read, word for word, or even character by character if you want, rather than speak the whole line of Braille at once. A student can get instant audio feedback as their fingers touch the corresponding Braille on the display. How cool is that?
Pretty cool.
Okay, let's dive a little deeper into this ATC stuff. With ATC, you can customize JAWS to respond in a way that benefits your Braille student. Basically, you can tell JAWS to do a bunch of things that aren't possible with other Braille displays. Here are just a few examples so you can get an idea of what I mean. You can have JAWS echo each individual character for a beginning Braille reader. So again, instead of speaking the whole line at once, JAWS will speak each individual character as the student's finger touches the Braille. You can also have JAWS speak each word as the student reads it. You can set it to do this as the reader reaches each new word, so that the student gets to hear the word just before reading it, or you can set it to say the word as the student reaches the end of the word, reinforcing what they've read. You could also have JAWS stay silent unless the student pauses on the word. And when the pause is identified, maybe you want JAWS to speak and spell the word. Well, it can do that too.
Nice.
Okay, before we show you some clips of ATC in action, we also wanted to mention the ATC monitor. The ATC monitor is a window that can be displayed on the computer screen. It shows a visual representation of what is displayed in Braille. And it highlights the finger position, making it easy to watch a student's reading session in real time. This can be very helpful for assisting with a student's reading session. Imagine, if you have JAWS set to silent and a student is struggling with a word while reading aloud or reading a large document, you are able to assist without interrupting the student's finger position. This is another feature that both parents and teachers find very helpful. Now, let's see this in action. In the video clip we are about to show you, a new Braille learner is reading the alphabet and ATC is set to speak each character whenever the student's finger touches the Braille. JAWS does not read the whole line at once like it normally does, but rather it speaks each letter only when the student reads that letter. And not only is the ATC monitor showing a visual representation of what is on the Braille display, but it is also highlighting the student's reading position. Let's watch the clip and see what I mean.
A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z.
Okay, that's pretty cool, right?
It sure is. Now that we've seen it in action, let's talk about how ATC works.
First, ATC can recognize 4 different reading behaviors. Because of those fancy sensors under the Braille pens, ATC knows when you are reading normal, reading fast, resting, and reading backwards. Normal reading is when the reading position is moving from left to right. Fast reading is when the reading speed is faster than X characters per second. In all cases, X is user-defined. For example, for a new reader, reading fast is going to look a lot different than a more advanced reader's fast reading. And because X is user-definable, that means we can define normal and fast reading, and even resting for each individual reader. Resting is when one character is touched for longer than X seconds. Again, X is user-definable. I usually think of resting as when a reader pauses to examine an unfamiliar word or character. For more advanced readers, this can be an intentional pause used to trigger a specific action. We'll give an example of that in a little bit. Reading backwards. This is when the reading position is moving from right to left, as when the reader revisits something they missed. This is sometimes called scrubbing.
Next, ATC and how it works.
So, now we know that ATC can detect 4 different actions. What makes that super cool is that you can set ATC to respond independently to each of the 4 reading behaviors. If you remember, when we watched the alphabet reading example for a beginning student, ATC was set to say current characters for all behaviors. This meant that every time the student's finger touched the Braille character, whether they read the character fast or normal, or if they paused on that character, they received instant and appropriate feedback. No matter where they were, when the student touched the letter D, JAWS said D.
So cool.
You'll see in the ATC Assistant Functions pop-up menu that there are multiple responses available for each of the 4 behaviors, making it possible to customize ATC for the maximum benefit of each individual student. Even better, these customizations can be saved as one of the learning profiles. Now that we know a little more about how ATC works and what it can do, here's an example of how ATC can be used to help a slightly more advanced reader. In this example, we have ATC set to echo words in normal reading and speak characters when resting. We've chosen the sentence "The quick brown fox jumps over the lazy dog" because it uses every letter of the alphabet.
Reading. Practice. Quick. Brown. Fox. Jumps. Over. Lazy. Dog. Q. U. Quick. Brown. Fox. X. Jumps. J. Over. Lazy.
Did you notice, in the example we just saw, that when the reader paused on a single character, even within a word, only the character was spoken aloud? That is just one of many settings available when using ATC. In this next example, we've created a more advanced reading profile in which the student, in this case Damien, no longer needs the constant speech reinforcement as he's reading. So, we've set 8EC to take no action when reading normal or fast, but we have set 8EC to speak and spell the word when Damien pauses or rests on an unfamiliar word. So, let's see how this works.
About Dream Vision Group. As a boy in school, I dragged a
Perkins, Perkins
Perkins Braille writer and volumes of huge Braille books from class to class on a little red
wagon, wagon.
Wagon. I read science fiction, dreaming of robots and
rocket,
rocket ships. Now I dream of sleeker, faster Braille devices, helping us leap time and space in a single
This ATC stuff is pretty great, but let's look at the question, how does ATC help teachers?
Well, for starters, ATC allows for the recording, playback, and analysis of reading sessions. In fact, each one of the sessions that we watched earlier was recorded to a reading log file. These log files could even be sent as email attachments. Now, a teacher can watch the reading session as if it were happening in real time using the log player. Additionally, the teacher can also examine all the associated data for each reading session using the log analyzer. On a side note, every Help Tech Active Series display, including the Active Braille, the Activator, and even the portable 16-cell Actilino, comes with a USB start stick containing manuals and useful programs. The log player and log analyzer are two examples of such programs. To recap, the log player is the program used to record and play back student reading sessions. The log player displays a visual representation of a student's reading behaviors. The log analyzer is the program used to collect, quantify, and export data from student reading sessions. Let's see the log player and log analyzer in action.
The icons for both the log player and the log analyzer are automatically added to your desktop when installed via the Start Stick. I'm going to start by opening up the log player. Click File, and I'm going to open up the alphabet session that we saw earlier. You'll notice that there are media buttons across the top. I'll go ahead and press play so that we can review this session. Finger position is indicated in dark blue, and cells are highlighted in light blue once they've been read. What's interesting about this session is that the student went back and forth between the E and the I, which are letters that are commonly confused with each other. Then we can watch as the student continues with the alphabet session. I'm going to stop here and open up a more advanced session for you to see. Again, you can see where the student's finger position is because the cells are highlighted in blue as the student moves through the reading passage. You can also note the date and time that the reading session took place because the program creates a timestamp each time it is started. Now that you have an idea how the log player works, I'm going to open up this same session in the log analyzer and show you some of the data that it records. I'm going to open the analyzer and again, go to File and open that same reading session that we saw earlier. Within the analyzer, there are several categories of data. Some of them are more relevant than others, so I'm going to focus on some of the more frequently used ones. Under the General tab, you'll see an overview of information such as date of creation, characters read, characters per minute, etc. The Reading Improvement tab shows data for each active minute of the session. Not only are the number of words, as well as the forward and backward read characters shown, but Analyzer also provides the number of unread characters. This information can be helpful when dealing with reading comprehension issues. Towards the bottom is the Character Set tab. This section breaks down the data for each individual character. For instance, the capital D was read 8 times in 8 different positions. We can compare that with the capital V, which was read 8 times, but in only 5 positions. That tells you that the student revisited that letter 3 times during the session. Any or all of these categories in the Reading Analyzer can be exported into an Excel spreadsheet, which is a great way to document student progress for IEP goals.
Believe it or not, there are even more ways that ATC can help teachers. There are 3 free Android-based apps that pair with most Active Series displays, including the Active Braille 40 and the portable Actilino. Just to note, the all-new Activator has its own Help Tech Plus app, but we'll talk about that one in a minute. For now, let's look at Tably, HT Echo, and HT Instructor. These free apps run on an Android tablet and connect to student Braille devices via Bluetooth. All 3 apps allow teachers to monitor and assist 1 or more students simultaneously, but each app also has its own benefits. First up is the Tably app. This app was designed for deaf-blind communication, but is often used as a Braille monitor because it shows what appears on the Braille display. The cool thing about this app is that a sighted individual can type into the connected app and their message will appear on the Braille display. As you can guess, this is not only a great deaf-blind communication tool, but opens up the door for many other uses. We've even heard from a teacher that uses it to do flashcards for her student. She just types in the vocabulary word, and the student reads it in Braille. She loves it because her student feels like they are playing a game. Who knew learning Braille could be so fun? Next up, it's the HT Echo app. This app can echo what is on the lead Braille display on up to 4 other displays. That's right. Whatever is on the teacher's display populates exactly on every student display. So teachers can use this when reading to a group to make sure everyone's on the same page. Nice, right? But there's more. We have a keystroke that allows the group to trade off who has the lead display. This means teachers can use this app to have a back-and-forth discussion with their students. Even cooler, deaf-blind students can use HT Echo to have a group chat. Pretty cool.
Pretty cool.
Is there an echo in here? Okay, let's move on to HT Instructor. This app allows teachers to monitor up to 4 Braille displays working independently. Yep, that's right. The app window is broken into 4 different sections, and each section can be paired with a different Active Series display. One student can be working on a paper, another on vocabulary words, etc. The teacher can monitor each student from his or her desk. Not only that, but a blind teacher is able to connect a 5th display and use that to toggle through each window as well. So, let's watch this clip and see what these apps can do.
Here is the Tably app that Greg told you about. A deaf-blind user is brailing a message that is populating on the app screen. Now, a sighted individual is responding via the on-screen keyboard, and their response is populating on the Braille display. Here is a demonstration of the HT Echo app. This app is mirroring the content from the teacher's display onto the student's display, while the same information is shown on the app screen. Here we can see that HT Instructor has populated the app window with the content of, in this case 3, but up to 4 active displays at a time. This can be used to monitor students working independently, and is fully accessible for blind teachers who can monitor via their own display.
If you were wondering about iOS apps for iPhones and iPads, we've got you covered. The exciting new Activator with the iPhone Smart Dock and Help Tech Plus app give iOS Braille users more streamlined functionality than you get with a traditional Bluetooth pairing on other displays. This is because the iPhone Smart Dock provides a wired connection with increased data capacity. This wired connection in combination with the free Help Tech Plus app from the Apple App Store is like turning your Activator into an iOS Braille workstation. In the Help Tech Plus app, you can switch on monitor mode to show Activator's contents on the iPhone or iPad screen. This is great for teachers working with students. There's also a live chat feature designed for face-to-face communication between deaf-blind Braille users and their sighted colleagues. The live chat feature is also a great way to dictate notes that can be saved as text or Braille files on the Activator for later review or editing.
I like it. How else is it like a Braille workstation?
The app also lets you send files back and forth between the Activator, an iPhone or iPad, or even an external USB drive storage device. This app will even perform OCR to convert inaccessible image files into readable text or Braille files. Finally, if all that wasn't enough, the Help Tech Plus app includes the Smart Services newsfeed optimized for reading current events on a Braille display. This is really helpful for doing research.
On that note, let's wrap up with some fun and games.
One of the games that comes installed on the Active Series displays is Braille Hunt. Braille Hunt is a fun way for students to practice proper tracking and build reading speed and comprehension. The game shows a line of Braille characters on the display. Each character is paired with a full Braille cell to show its exact position within the 6-dot matrix. The player checks the first character, then reads quickly across the line looking for a match. When they think they have a match, they stop or rest on that character. ATC will announce whether they were right or whether they need to try again. If they take too long or scrub too much, ATC will also play the try again sound. Fun! Additionally, the classic game of Hangman is also included. This program can be set to include any words you choose, so your student can play using their spelling or vocabulary words. Wow! Yet another way Active Tactile Control helps Braille learners, and makes it fun at the same time.
You mentioned MusikBraille. What's that?
Well, those cool Braille cells in ATC allow for a unique Braille music editor called MusikBraille. Tones are played both when notes are typed and when they are read on the display. So, students can pick out individual notes on a scale with their finger, like a keyboard since the Braille knows where your fingers are, or they can compose entire melodies and then play them back. You can also choose from a variety of musical instruments such as piano or even the steel drums.
Nice! Is there a video for MusikBraille?
You bet there is. Let's watch. Here is Damien on the portable Actilino. He's in the music editor, which allows him to hear the tones as he enters them on the Actilino's keyboard. Once entered, he can move his fingers both forward and backward along the Braille cells to hear the notes. Likewise, he can type space P to play back what was written. Damien can even pick notes randomly to try his hand at being a composer.
Nice!
The MusikBraille editor on the Active series also allows you to save your files to open up and play back later. So that's a little bit of how MusikBraille works on the Active series.
Okay, so let's review.
The HandyTech Active series are the only displays with the patented ATC technology. Again, these are those curved ergonomic cells with sensors under the pins, making the unique features in this presentation possible. The Actilino, which is a portable 16-cell display, and the Active Braille, which is a 40-cell display, are both part of the Active series and have been the most popular choices for our education customers so far. Likewise, the Active Star, which is a 40-cell display with removable QWERTY keyboard, and the Modular Evolution, which comes in a 64-cell version and an 88-cell version, are also part of the Active series by HelpTech. These displays are more popular with college students and working adults. And that leaves us with the Activator, the newest display in the Active series and hands down one of the most powerful and unique Braille displays in the world. Not only does the Activator utilize ATC and all of the unique benefits that this technology makes possible, but the Activator has some additional features that are quickly making this display popular among both students and working adults. First, the all-new Activator has a 2-in-1 Perkins QWERTY keyboard.
What?
It is a 2-in-1 keyboard. There is a Braille keyboard just above the cells and it flips open to become a full QWERTY keyboard. Switching between the two is seamless. All you need to do is flip open the QWERTY to use that input, or fold it closed to use the Braille input.
Wow!
There's even more. That HelpTech Plus app that we talked about earlier. Well, that is made possible because of the iPhone Smart Dock and its wired connection to either an iPhone or an iPad, and it is why you get so much more functionality than any Bluetooth connection.
Nice! I can easily see why this is quickly becoming one of our most popular displays.
Well, that wraps up our presentation. Thank you for joining us. We hope you enjoyed learning about how active tactile control can benefit teachers and students.
To learn more, or to find a dealer in your area, email us at info@dvg-llc.com or give us a call at 512-662-1629. You can also visit our website at www.dvg-llc.com.
Dream Vision Group.
We'll meet you where you are.
You tell us where you want to go.